Hey there, code warriors! Welcome to day 8 of our 30-day JavaScript challenge. Today we will take on a really fun and surprisingly a tricky problem: palindrome numbers. This one comes up often in interviews and can trip up beginners. But don't worry, I will walk you through it step by step, so even if you are totally new, you will master it like a pro by the end of this video. So first thing, what is a palindrome? So a palindrome is a number or a word that reads the same forward and backward. Example, 1 to 1, it is a palindrome. Okay, you can read it also from other side, 1 to 1. -1 to 1 reads 1 to 1 -1 backwards, so that is not a palindrome. Now 10 reads at 0 1 backwards, which is also not a palindrome. So today's task is to write a function that checks if a given number is a palindrome. If it is, we return true. If not, we return false. Now, we need to break down this problem before we start really writing code, and that is a very crucial step. Now, to solve this problem efficiently, this is our plan how it will be. First thing we have to do is check for any negative numbers and trailing zeros. So negative numbers are not palindromes since they have a minus sign at the front. If the number ends with 0 like 10, it can't be a palindrome unless the number it is 0 itself. So that is an edge case. Now, the second thing is we need to reverse the number. So extract each digit from the end and build a new reverse version of the number. So we'll start building from the end of our inputs. Now, third thing we do is compare the original and reverse number. If they match, the number is a palindrome, otherwise it is not. Now, let's write our code and we'll do it step by step as well. So here I defined a function and I add a cancel log with the test scenarios so we can run them later to test if our code is working properly. Now, first in our code, as we said, we need to handle those edge cases. So the step number 1 will be to check if the number is negative or the number is ending in 0. Those can't be a palindromes, okay? So let's run that check first. Step 1, handle edge cases. So we'll say if the number is smaller than 0, so that will be a negative, or if x divided by 10, so the remainder of it is equal to 0, okay, and of course the x should be different than 0. So in this scenario, we have to return false, means your number is either negative or you can multiply it by 10, which means it's ending by 0, therefore they are not palindromes. So we return false. Now, after we did the edge case scenario, let's define some variables that we will need. The first one will be our reverse number. So we have to create a variable, let reversed. Okay, and that will start from 0, and this is the one we'll be storing and building our new reverse number. And the second variable, it will be actually storing the original number so we can compare it later, because in our code we'll be modifying that original number. Okay, so we want to keep a copy of its actual the one that we got as an input in our function. So I'll call original, and that will be equal to x. Now, step 2, we'll be now reversing the digits. So reverse the digits. Therefore, we have to be looping to our number. So we'll be using the while loop. So we'll say while our x is superior than 0, then do the following. Okay, as I said, we'll be modifying the actual x, so we'll be using this while loop here. So as long our x is a valid number, we will create a new variable called digit. Okay, and that will be the last digit on the right, and the way you can extract it is using the division and getting the remainder. So x divided by 10 So this one will give us the remainder of this division. So this one will give us that last number on the right. Now, what we will do, we will go and build our new numbers, which will be stored in this reversed variable. So the way you can do it, we are building from the end, which means every time you create a new digit, you multiply it by 10, so it moves to the left, okay? So you have a space on the right side for the new number. So reversed will be actually equal to current reverse we have before our change, multiply by 10, so I'm moving it 1 unit to the left, and then adding our new digit. After that, we need of course to remove our last digit that we added to our reversed. We have to remove it from our x, and that's very easy as well. So we'll say x is equal to math.floor, okay, and we will be dividing x by 10. So this one basically what we'll do, we'll remove the last digit, okay, from the original number. So basically this code will keep running and going in this loop until you finish your x, means you finish all the digits and you build up your reverse number. So when that is completed, now we come to step number 3, which compare the original to the reverse, okay, which is very simple because are numbers. So we'll just return a comparison. Is our reverse equal to original? Okay, now before I run this code again, let me go through this algorithm step by step. So step 1, we made sure we are handling that edge case, okay? So, and me and my Spanish with an A, so we should be handling our edge cases. So if the input is negative, like minus 121, we have to return false because it can't be a palindrome. If the number ends with 0, like a 10 or 20, and it is not 0 itself, we return false since 01 or 02 is not valid. Now, the step number 2, we have to start reversing the number. So we use a while loop to keep extracting digits from the end, and each time we add the digit to the reverse number and remove it from the original number. For example, for number 121, we extract this 1 from the right, and reverse number now, which is this one, will have number 1. Then we go in the while loop in the second round and we extract number 2, okay? Now our reverse number will become 1, 2, and our x will be just 1. Next round, we'll extract 1, okay, again, and then the reverse number will have now 1, 2, 1. Our x will be 0, then our loop will break, and then it will go into the next step. And that is the last step. We will compare the numbers. If the reverse number is equal to the original, we return true. If not, we just return false. Now, let's go ahead and run our code and see if this is working. And that's not working because I forgot this here. Let me comment it out. Let's run this again. And there we go. So this one is saying it's palindrome, which is true. This one saying false, which is correct. 10 also is not a palindrome, so this is correct. And 0, as we said, that is a palindrome because 0 is just one digit number, and any digit number it will be a palindrome, so that is true as well. This code is also very efficient within the time and space complexity. It means in this scenario, the time complexity is OD, where D is the number of the digits in the number, and the space complexity is O1 since we're only using a few variables. And there you have it. With just a few lines of code, we have solved the palindrome number problem. This solution is super efficient, easy to understand, and ready for any coding interviews. If you found this helpful, make sure to like, comment, and subscribe for more daily JavaScript challenges, and let me know in the comments what numbers surprise you as a palindrome. See you tomorrow for day 9. We have got another exciting challenge waiting for you.